Good day, everybody, and you're most welcome to today's CNPS presentation. It's one of these fortnightly alternative sessions that we hold, dealing with fairly fundamental problems in physics, maybe theoretical problems or philosophical problems as well. We try to keep things reasonably simple, but we're not shy in introducing advanced concepts because they may be necessary at the time. Now, today, we're very honored to have an old stalwart of our dissident physics community, Dr. Dennis P. Allen. I must apologize. There are a couple of imprecisions in the announcement. First of all, his middle initial is P, not J, P. Allen Jr. And in the announcement, actually, unfortunately, the first few words are just the words of last fortnight's session, and we've put the title erroneously on top of that. So basically, the title for today's talk is merely Electrostatic Capacitance Gravity Theory. And Denny has done a lot of work on this, and he basically says that it does Einstein's general theory of relativity's religion of mathematical beauty, one might call it that, coincide with the physical truth of experimental gravity? So that's a fundamental question. And just a little more detail. So as I say, transverse relative time shift, that's from last time. Just delete that. Electrostatic capacitance gravity theory. And establishment physics admires, evidently, Einstein's GRT gravity theory because of its perceived great mathematical Riemannian four-dimensional geometry and its curved space-time beauties. But does this religion of mathematical beauty coincide with the physical truth of experimental gravity? No, because it's based upon the assumption that gravitational and inertial masses are the same, or at least always equal. But Russian professor Alexander L. Dmitriev has done a number of experiments showing that horizontally fast spinning rotors do not usually fall with the usual local gravitational acceleration. Furthermore, Morton F. has given a model of gravity that involves spherical capacitors, modeling both electrons and protons, which tends to explain why Newton's gravitational constant G cannot be calculated accurately to more than 5 significant figures. That is due to the local permittivity or dielectric constant, then being a hidden variable in Newton's theory. So this is most interesting concept, drawing on sort of analogy between electrostatic modeling and gravitational energy. Now, here's one of the little booklets that Denny actually has compiled on the area, and we'll be referring to this later. Morton F. Spheres, the late Morton Spheres. Okay, foundations of neo-Spersian gravitational theory with application to earthquake early warning systems. He'll be telling us all about that. So there's a lot of material here for us to consider. And as usual, we'll be giving the speaker an hour and more. If he wants more than that, that's fine. Normally, if he has an hour, it will leave an hour for the discussion subsequent. But if he wants to take another 15 or 20 minutes, we're not going to stop him. No, that's fine. We'll just have a shorter time for questions and answers. And again, if you'd like to put any specific questions in the comments, maybe highlighting if they are questions rather than just comments between participants, well, then we can hold those later so that we can address them to Denny. Right. So so I think it's time now to hand the floor over. Denny has supplied me with about 5 files, one of which is the book I've just referred to, and I'll be projecting them when required. But I obviously need to be told when to do that. I'll have to share my screen, so there might be a little delay when we do that. You will bear with us, I hope. So what I'm going to do is I'm going to bring our speaker up. I'll stay up myself for just a moment in case there are any teething problems. If you're happy, Denny, I'll give the floor to you. I'll bring myself down, but you tell me if and when you want me to project anything in particular. Okay.
Okay. Gravity is the topic, really, in different theories. The background for gravitational theory is, of course, Newton's universal theory of universal gravitational theory, and then, but nowadays, physicists at the universities don't hold so much with Newton's gravitational theory, but rather with Einstein's general relativity theory, which was a gravitational theory and involved curved space-time. Well, space-time was actually not invented by Einstein, it was Minkowski. But the idea was that according to Einstein's special theory of relativity, time can become space and space could become time. And so that space and time were basically the same. And this was heralded by a lot of people because it seemed to finally lay to rest the claims of Christianity that time travel happens universally throughout the universe and doesn't merge into space at all. So it seemed to drive the final nail in the coffin of Christian culture and theology. But it turned out that that was incorrect. The GPS people, especially Ron Hatch, who was the last of the great GPS people, who's now dead, unfortunately, pointed out that the time, at least among the inner planets, does advance equally throughout and that the fact that the clocks don't measure that to be true was because the clocks, the cesium atomic clocks that they use to measure so precisely tend to run at different rates in different gravitational fields and at different velocities. But you would think that this would mean that they would apologize and dump SRT and hence GRT2, which is curved spacetime. But of course, that's not the case. They claim that GPS follows from the special relativity and the general relativity. It's not contradicted by it, as Hatch pointed out. So, but that's not the only thing wrong with SRT and GRT. The equivalence principles, excuse me a second, I had a phone call. The equivalence principle says that gravitational mass and inertial mass are the same. And this turns out to be incorrect too. The equivalence principle was, the idea was that led to what was known as the elevator thought experiment of Einstein's, where if you're in an elevator and it's accelerating upwards at acceleration, say lowercase g, then if you can't do any experiment in that elevator, that would give a different result if instead of being in the elevator, you were on the surface of the earth where the acceleration is g. And that led to curved space-time and then curved space-time. But that's incorrect. It's now known, as the Russian professor Alexander Dmitriev points out in an article. Go ahead and put the the Dmitriev file up, will you please, Ian?
I'm trying now. It'll just take me a moment.
Okay.
Well, once we have this up, it should be more straightforward the next time. Is that the one?
Yes.
Okay.
Can you scroll down a little bit? Ian? A little more, another one.
I'll just see. Let me see now.
Yeah, okay, there's a plot of his data. What he was doing was he had what he called an aviation rotor, and he was spinning it at different angular velocities, but always with the spin axis being horizontal, not vertical. And the faster he spun it, as you go to the right, from left to right in the plot, you can see on the average the acceleration that the rotor falls in an Earth's gravitational field tends to become smaller. That is below, towards the bottom rather than towards the top. And there are oscillations, though. And at the time, Professor Dmitriev pointed out that that there was the situation was complicated because it's only on the average that it goes downward as you move from left to right. But later research has shown apparently that this was because the rotor wasn't ground precisely enough. And so it was like a top-loading automatic washing machine. If you start on the spin cycle, it begins to spin up and up and up, which would correspond to going from left to right in the diagram. And if it's unbalanced, it'll hit a certain frequency where it resonates. It'll be going up and bang, 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 bang. Bang, 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 bang. So in other words, it's an apparatus effect as far as jumping up and down like that, and only the average, fitting a quadratic curve, a least fit curve to this will get rid of a lot of that noise from the fact that the rotor wasn't ground precisely enough. But that's the main thing is that you can see that these rotors do not always fall at the same acceleration. So if you did this experiment in an elevator that was moving upwards with acceleration g, then the rotor would apparently fall. Let's see now. Let me get this right. Well, it certainly wouldn't fall at the same. It would appear in the elevator to either go up or down depending on where you were in the plot. But that's contrary to the equivalence principle, which says that no, everything falls at the same rate. So the equivalence principle is contradicted by this data. And this isn't the only thing, data. Could you bring me up again, Ian?
Shall I get rid of the slide, Danny?
No, that's all right. Just see, I've got a book here written by Professor Dmitriev. Every single article refutes special relativity, or general relativity, I should say, the gravity. And this book is entitled Physical Gravity. And why physical gravity? Because general relativity is geometric gravity. It talks about curved space-time and Riemannian geometry. Whereas Professor Dmitriev's book, Physical Gravity, is about actual physics, effects, forces, and so on. And but he's getting nowhere. He put in an application for an experiment in outer space where you can get a lot better data. Your data is much more precise. But they aren't going to let him do that, I don't think, because it would refute special and general relativity both, especially general relativity. So that's in Russia, things are a little better than around here. Here, if you even talk seriously about overthrowing Einstein's general relativity and you were in academia, you'd be gone. You'd be history unless you were at some real small college that no one really cared about. And why is this? Well, it's because of making physics into a religion. There's a YouTube video, which I strongly recommend you view, entitled Paul Dirac and the Religion of Mathematical Beauty. And it's pointed out there that Dirac had a very unhappy childhood. His father was extremely domineering, and realizing that Dirac had a very high IQ, in the morning when they had breakfast, Dirac was nervous like a lot of high IQ people and had to go to the bathroom a lot. And his father, every day would refuse him permission to go to the bathroom. So he went in his pants, apparently. And, that was not a real happy childhood. And his father was very domineering, and he had a brother who was not as bright and was not subjected this way to humiliation. And he and Dirac and his brother became estranged, and to the point where if one was walking towards the other on the sidewalk somewhere, one would cross the street so he didn't have to say hello to the other. And then, if that weren't bad enough, his brother committed suicide, which I'm sure made him feel even guiltier. And so the reason for the religion of mathematical beauty, according to this YouTube video, was that's how he kept from committing suicide like his brother. He would start thinking about beautiful math and Riemannian geometry and so on. Dirac was known, Paul Dirac was known, one of his biggest triumphs was bringing quantum mechanics of Niels Bohr and others into line with special relativity, which is space-time, according to Minkowski. And so that was his antidote for all his unhappiness, was this religion of mathematical beauty. And there was another Englishman who was also involved heavily in this. It was Hardy, a guy by the name of Hardy. Hardy and Wright, a colleague, wrote a book on theory of numbers, which is very it sold a lot of copies. It was well received. And Hardy wrote a book, Mathematician's Apology, where he said that mathematics is in two camps. One is pure mathematics, which is wonderful and beautiful and so on. And the other is applied mathematics, differential equations and so on, which is useful and low, and not too beautiful. And Hardy is apparently another very unhappy person. When he shaved, he wouldn't use a mirror because he thought he was so ugly. No one else thought he was ugly, but so he must have had a terrible childhood too. And so he, even in mathematics now, applied math is not considered to be on the same level as pure math. And at least when I got out of school in 1968, that was the case. Things could have changed since then. But the third man, the third party that went in with this mathematical beauty was the Einsteins, Mr. and Mrs. Einstein. I mentioned Mrs. Einstein because she won all kinds of honors when she was at the university in Europe in mathematics. She was just a brilliant mathematician, whereas Albert was a so-so mathematician and could only get a job at the patent office in Switzerland when he got out. But the problem with that Mrs. Einstein had was that she wasn't too attractive physically. And so the marriage was viewed as a marriage of convenience. And it's believed by a lot of people that most of the Riemannian geometry and so on was due to Mrs. Einstein. And so she was married to Albert, and then he divorced her after he won his Nobel Prize. But when in the divorce settlement, she won every single penny he won in the Nobel Prize, and it was over $1 million, I think. In those days, which was a lot more money than now. $1 million would be now. And but she was evidently very unhappy nonetheless, even with all that money, and ended up in a mental institution for a while. So you see, the three main people that I know of in this religion of mathematical beauty all were extremely unhappy and miserable. And but now that religion has caught on through all of the physics, really, especially foundations of physics. And so you just have to deal with it. And a religion can't be refuted by facts very well. That's unfortunate, but that's the way it is. There's all these proofs that especially general relativity is wrong, but nonetheless, it's promoted by big academia, the physics elite, and that won't change unless there's another religion which will replace the religion of mathematical beauty, because you can't refute a religion by facts. You have to convert the people religiously. Well, all right. Now, could you bring up Smallsky, Joseph Smallsky's Ian?
Okay, just give me a moment. So what's the name of the file again, Danny?
Smallsky, I think.
Oh, yes, I have it here. Okay, just give me a moment. Gotta go here now. Smallsky. Sorry for this delay. The first thing, I'll take that down. Try to put the other one up. Remove that one. Oddly, it seems to be having problems with this one because it's not PDF, it's in Word. It shouldn't make any difference, but maybe I should convert it. Not sure why it's not taking it. See now. Let's see, can we get that? Can I get this up now? Okay. Don't know why it's not accepting it.
Well, I'll just.
I should be able to get it up. I should be able to get it up. There's no reason why it's refusing it. Share screen. See now. This is on the perihelion motion of Mercury, I think.
That's right. Yeah.
Don't know why it's not taking it. Let me just try again.
Well, maybe it's just a bad file.
It's a Word file. The others were PDF, but that's no reason why it won't accept it. Let's see. I had it up on the computer here. Let me see. It seems to want a PDF file.
Well, can you convert it to a PDF?
Yeah, well, I could do that if you give me a moment. I was going to do. I've done it actually already. I have it in PDF here. So let's see. I've done that. Yeah, I did that a moment ago. So let's see. Does it work now? There's some strange anomalies. Is that all right now?
Yeah. This is an article by a Russian professor, Joseph Smallsky, who works, I think he's past time now, but he worked in supercomputers, and he was his location was Siberia, which doesn't exactly pin it down. Siberia is huge. But anyway, one of the things he did with his supercomputers was he reasoned as follows. He said, the sun rotates. Now, because of centrifugal force, that means that it'll bulge at the equator and be narrower at the poles, like the Earth, for example, which rotates. And so he said, well, maybe I can explain the advance of the perihelion of Mercury, which is one of the big triumphs of general relativity. Maybe I can explain it by Newton's gravitational theory if I take into account that the sun is rotating, which we can tell because the sunspots go by. And also, so then it bulges at the equator and is narrower at the poles. So and then, of course, you have to take into account all other planets too. So you do need a supercomputer for this, but he had one, and so he tried it out, and he found he could explain the advance of the perihelion of Mercury under these assumptions that the sun rotated, therefore, by centrifugal force, it was larger at the equator and smaller at the poles. And so you don't even need special general relativity to explain the advance in the perihelion of Mercury. So that's another thing about general relativity, that you don't really need it. Also, the other big thing is that during an eclipse of the sun, some English expedition measured how the starlight, when the sun was in an eclipse, so you could see the stars near it, how the star's light was bent by the Earth's gravitational field. And the expedition, I forget who was in charge of it, some Englishman. The expedition claimed that they got the right answer for the bending of light around the sun during the eclipse using general relativity, Einstein's general relativity, whereas Newton gave a wrong answer. But since then, people have noticed that, one, they look at the notes of this guy who did this expedition to do that, this Englishman, and they find that he cherry-picked his data. And people also have noticed that the sun has an atmosphere, just like the Earth. Now, on the Earth, if the sun is going down in the west, you can still see it even though it's below the horizon a little bit, because of Fermat's principle, which was that the light bended down as it went into the atmosphere, and so it didn't move in a straight line. And so therefore that you could see the sun even though it had gone down a little bit. And since the sun has an atmosphere too, maybe Fermat's principle could also explain this other property that was of this expedition measures bending of starlight around the sun. And they find that it does seem to explain it. So it's just Fermat's principle all over again. So that was the other big thing about big experiment that was supposed to say that general relativity was correct, and so you better believe it. The whole thing is a hoax, apparently, sort of. And there was one other item. Don't they use general relativity in NASA to chart the spacecraft's how they're going to proceed, what trajectory? No, NASA does not use Einstein's general theory of relativity to help with their rocketry, nor does SpaceX, it turns out. They use Newton's theory of gravity for this. So no matter how you look at it, general relativity is contraindicated, but it's doing just fine in academia. because it's become a religion. The facts, you cannot refute a religion very well with facts. That's unfortunate, but there it is. All right, so that's the background. Now let's get into, you bring up the next, no, that's going back one. You got to go advance one.
I'll remove it. Okay. So the next one would be new theory. Excuse me. Let me see. New theory of gravity.
No, it's one after
Yeah,
that.
by Ronald Hatch. Is that the one? It's Hatch's paper.
Yeah, I've already talked about Hatch, so let's move on to the one after that.
You don't want that. The one after that is the page from the book relating to Morton spheres.
Oh.
Do you want that?
I hope I have. Don't you have one an electrostatic solution for the gravity force?
So the next one, I've only one more, is it's actually the book you wrote.
Yeah, I think I really messed up.
Neo-Spheresian gravity. You want something else?
I think I left out the most important one. Can't believe I did this. I'm going to have to send it to you.
Okay, or you could put it up yourself. What is it?
It's Spears' paper.
Oh, Spears' paper itself. Well, if you want to send it to me.
Yeah, I'm trying to do that right now.
Okay.
I can't believe I left that out.
That's easy to do. I only read these things about an hour ago as well. So I better go into my email to see, have you sent anything to me?
Well, yeah, I haven't sent it yet. I got it.
Okay.
Okay, I'm getting there.
Because you could also do it by sharing your own screen without sending it to me.
Okay,
if you prefer.
Let's see. Okay. Just take a minute here.
Yeah.
I can't believe I did that. I can't seem to send it.
Okay.
Let me see. Maybe no, I can't. I guess I can now. I guess I finally can.
Well, if you wanted to put it up on your own screen and then share screen. You can
Well,
do that.
I'm having some trouble here.
Or alternatively, just tell us about it, because there probably won't be the possibility of reading it all on the screen anyway.
No, but I need the diagram on page 1.
Right.
It'll just take a minute here. It's, my computer is slow.
I mean, if you can just send it to me as an attachment, I'll pop it up.
Yeah, I'm trying to now. I clicked on bring attachment, but it was trying to bring up the
It's not a big file, I take it.
no. But my computer is I have to use an old computer so I can use the right file. Keeps giving me no internet connection. Oh, here we go. Oh, God, here we go. There we go. I'm attaching it now. I'm attaching the file now.
Okay. Let's see, has anything come in? No.
Still not attached. Okay. Just put your address here.
Excuse me.
Okay, I hope that's just gonna. I'm gonna send it now.
Oh, you're going to send it to me. It'll still take a moment or two.
Yeah, I know it.
A few minutes maybe to go through.
I don't know. I hope not. A few minutes.
I don't think there are any specific questions coming.
Okay, it's gone.
Okay. Oh, wait a minute. It's come in. Okay, hold on. Right. Right. First of all, I have to download it.
It's a PDF file, so you shouldn't have any trouble.
Okay. Well, let's.
I need page 1.
You need page 1. Okay. Let me get it here. Electrostatic solution, right? Okay, let's see, can we get it up now? Okay. It's processing it. Here we are. It's up now. Is that it? All right.
Yeah, that's it. That is it.
Okay.
Well, this is the first page of a several-page article by Morton Spears, although his daughter was the one who was a professor of economics at Midwestern University, a big one, submitted it. He died before he could finish up. But the diagram on the lower left is the key to the thing. We're modeling protons and electrons by spheres that are conducting spheres that are just shells. There's nothing inside, no charge or anything. So why would we want to model it as spheres of that are charged, either positive with a quantum of charge or negative in case of the electron with a quantum of charge? And this is a 2-hydrogen diagram. The top on the top, there's the larger spheres are correspond to protons, and the smaller to electrons, according to this model. And so he wants to start out with the simplest case, 2 hydrogen atoms. That's a neutral because they're not ionized. But look at the gravitational force according to Newton, and compare it with the gravitational force in electrostatics, and see if they don't agree, which it turns out they do. First he makes the point that even in a hydrogen atom, the electron and the proton are really very far apart compared to their radii, which are small. And so you have to take that into account. Now, he wants to just look at the hydrogen atom on the bottom, where the electron is on the left and the proton is on the right. And the electron at the top inside the oval there, and he's leaving out the proton for the time being. And he's wondering, is there a higher order force? Because here we've modeled protons as spherical charged balls, shells, and electrons as smaller spherical charged spherical shells. The fact that one is larger than the other, does that have some kind of an effect on the situation? If they were all the same size, they wouldn't be, but it turns out that the proton is about almost a little over 1,800 times larger in radius than the electron. That comes from the fact that the proton-electron mass ratio is about 1826 or 1836, maybe. Yeah. And the answer is yes, but only a very slight effect. very, very slight. However, and this is a kicker, this is the important point, because things are so weak, there's not cancellation and only addition. Like now, in electrostatics, an electric charge and a negative one and a positive one go together and they neutralize. So you can go up and down, but with this new force that he's just, getting out of this diagram, that's not quite true. It turns out that there's always attraction between two hydrogen atoms, although very weak, about 10 to the minus 40th weaker than it would be if you just had a proton at the top and a proton at the bottom, or an electron at the bottom. That would be attractive too, but it would be about 10 to the minus 39 times this new force is so extremely small compared to the column force, but it turns out it's about the same as the gravitational force. So this no force seems to be a gravitational type force. Okay, now let's see here. All right, now I have to mention that the reason it took him a year to the point where he actually died and his daughter had to finish up was that he had terrible dimensional analysis problems in doing this. It turns out that this new field, which we're going to talk about here, has as units not volts or anything like that, but it has as units coulombs, which is a unit of charge. Now, so he calls it a column force because he doesn't have any better idea, he says. So you can see that right away there's going to be dimensional problems all over the place with this. And but he finally felt towards the end of his life, before he died, that he'd cracked this dimensional problem. But it involves contortions that are, quite involved. And so I'm not going to have time to go into that. But the point is that he finally made it so that he didn't just get right answers in the MKS or SI system, but in any system, because he got the thing to be dimensionally correct, which guarantees that if it works in the MKS, it works in the CGS and other such things. All right, so let's see here. The thing about the second one is it's so weak, 10 to the minus 40th, that it doesn't, there's no displacement. I mean, everyone's heard of, studied electricity, Maxwell's displacement current in a capacitor. First, if there's a positive charge on the left and a negative charge on the right plate, and there's a dielectric in there, then the electrons in the dielectric tend to pull towards the positive plate, whereas the protons tend to pull towards the negative plate. And there's a shift in their relative locations. And if you use alternating current, then the shift goes back and forth, back and forth. And so it's like a current was going through the dielectric, even though it doesn't conduct. But there's no displacement, and hence no displacement current when it comes to this column force gravitational field that Spears is talking about. And this means that the force is always attractive. It's not repulsive. Now, that's fortunate, of course, because gravity, there's no such, even they say that maybe antimatter would would repel matter, and so there would be a negative gravitational force, but no one has ever really shown this. This is just mere speculation. Okay. And of course, that's why this Coulomb force is important, because it's always attractive. So if you have something like a planet, Earth, Mars, or a moon, like our moon, or Titan is the moon of Saturn or Jupiter, I forget which, they have so many atoms that even though we have a 10 to the minus 40th discrepancy, nevertheless it adds up to something that's quite substantial. Okay. Now he uses the term elastance as a reciprocal for capacitance, which is measured in farads. Capacitance measured in farads, where elastance is measured in Daroffs. Daroff is farad spelled backwards. So, and this unit is not used too much anymore, but it is used in the third edition of Static and Dynamic Electricity by Caltech professor at the time, William Smythe. And so it is definitely still used, but not too much. Anyway, Daroffs seem to have the same dimensionality in this theory as meters. That is, their length. You can see in this diagram that you have three capacitors. One at the bottom left, the other at the bottom right, and one at the top. And no, excuse me. That's the capacitors are between position 1 and position 2, and between position 2 and position 3. And I think there's another one going to. We have capacitors between the ground, position 1 in the ground, and between position 3 in the ground. So there's a total of 4 capacitors. Let me repeat that since I kind of messed it up. There's one between position 1, which is the lower electron, and position 2, which is the upper electron. And there's a capacitor C32 between the top electron and the bottom proton. And then there's a capacitor C1 between position 1 in the ground, and C3 between position 3 in the ground. So those are the capacitors and we're talking about farads and their reciprocal, which is Daroffs. If there's 3 farads capacity between position 1 and 2, then there's 1/3 Daroff elastance between positions 1 and 2, and so on. So Daroffs are the mathematical inverse of farads. And farads has 1/r in the formula, so the Daroffs have r in the formula rather than 1/r, because 1/r is r. So but what is the relationship? They're a constant multiple of each other, but what is the relationship between them? Well, it turns out that it's about 8.8 times 10 to the minus 40th meters in a Daroff. That's 8.8 about times 10 to the minus 40 Daroffs in a meter. A meter's in a Daroff. I'm sorry, I'm getting confused here. Yes, Daroffs are hugely smaller, or extremely smaller than meters. but they both have the same dimensionality. Okay, okay. Also, Spears does not use neutrons in his theory, only as mass, because they have mass. He introduces them as mass, but he does not consider them to be a proton and electron in close position with maybe a neutrino thrown in, which has no charge and almost no mass, which I do in my book. I change things a little bit. Okay, can you, well, maybe I better start to ask for questions now. My hour is up, so maybe we better have a question, and then I can go on later on if there's time permits.
Right. That sounds like a good idea, because a few points have been coming in, and maybe Denny can address those, and if necessary, one can have a longer discussion on some aspects then that we may have to revert to.
Yeah.
Okay, well, I'll take the that down. See now. Remove. Okay. So thank you very much. I mean, you've covered a lot of information there, and some of this I've seen before, and yet it's still quite difficult to grasp. But I think some of those documents you referred to have been illuminating, and you've also brought in some interesting points about Paul Dirac that I wasn't aware of. And you've also mentioned that this maybe perceived cherry picking of Eddington in the 1919 experiment to try to show that there was a different deflection on starlight, which was grazing the sun, from that which would be inferred by Newtonian calculation. And maybe the paper there, it's very verbose, and there are a lot of modifications and check plates and all that. Maybe it was really little more than cherry picking, although it's become accepted canon in science now. And yeah, the Russian, the Dmitriev equipment as well. There was one question here actually, which I think I might have an inkling of what you're going to say, but Kevin Kahn has said, has Dennis heard of the pulsar timing array experiment that indirectly detects gravity waves as predicted by GR?
Yes, I don't know. I've heard of that they detected gravitational waves, but that's via LIGO, LIGO, and some similar sites. Pulsar timing. I don't know much about that.
But I think it might be fair to say that many of us have expressed some skepticism about the objectivity of those experiments. You know,
But you know, there still could gravitational waves. For example, a guy I know, Harvey Fiala, wrote his thesis under Richard Feynman at Caltech, his master's thesis on Newtonian gravitational waves. And so gravitational waves are not ruled out by what I said by any means. They're certainly, but GRT gravitational waves are tensor waves, not vector waves. And so you pick them up with different equipment. And you know, there's still, even if GRT was completely and totally incorrect, which I believe it to be, there still could be gravitational waves because other theories predict gravitational waves too.
Yes, and furthermore, I mean, the existence of gravitational waves in no way might be taken to indicate that that is the be all and end all of the
Yeah.
force of gravity, of the interaction. So, in other words, you can have gravitational waves which are basically etheric vibrations, and the speed of transmission of those would be in accordance with the similar formulae. But that doesn't mean that the force of gravity is brought in by those waves. I mean, the force of gravity can have maybe a speed which is orders of magnitude greater than the speed of light, whereas the gravity waves themselves might not be. Yeah. Okay.
Well, it's like in the Earth, there are both, when an earthquake occurs, there's both vector pressure waves and there's tensor twisting waves. And so tensor waves can pass through the Earth too. As I say, GRT predicts tensor waves, not vector waves. But it's as Feynman pointed out, it's not enough to detect gravitational waves and all the other things that GRT predicts. But even if you have a million such experiments all successful, it only takes one experiment to refute the whole works, because that's it's just a matter of logic. But to be honest with you, I haven't really. I'm not really into pulsars and so on. There's another message that came up here.
There's a private chat. I've just.
Nick says, I don't know whether you'll be able to hear me, even though my mic is working fine. Can you bring it up, Nick?
Yeah. Oh, okay. I was going to.
Here's James Arathon here.
Yeah. Just one comment here, James, and then we can go into the green room, and I'll address Nick's point. But he just asks: is there a polarized ether in this model? Polarized.
In what model? You mean in capacitance gravity?
Probably yes.
There's no ether. Ether is left out of the thing, just like in Newton's theory of gravity. However, if there is an ether, it's going to have to be a different ether, because gravitational interactions, and I believe it was pointed out by, in the far planets, if gravity traveled at the speed of light, the far planets would spin off into outer space. Maybe you can remind me, Ian, who was the one who wrote that book and then pointed that out?
Well, a number of people. Actually, Eddington himself pointed that out quite early on.
I'm just my memory's not working too well here, but
yeah. In fact, going back much further, this is possibly what you're thinking of, Denny. It's Laplace himself, the mathematician.
No, this is fairly recent. I'm thinking of, and it was in that book, Kelly's book.
In Kelly's book, because a number of people have pointed this out. Yeah.
Let me see if I can dig up Kelly's book.
While you're doing
that, modern physics. Yeah.
Okay, indeed. I think he refers to Eddington. I'm not sure if he refers to Laplace, but I'm not quite sure.
No, this is someone recent.
Okay. Oh, wait a minute. I'm coming now. My mind is gone as well. It's Van Flandern.
Yes.
Yeah.
Van Flandern did the math and pointed out that if gravity didn't travel extremely faster than the speed of light, then the outer planets would spin off into the universe, outer space.
And because of
And this means that an ether, the usual Lorentz ether has the velocity of light plays a heavy role because that's how electromagnetic things propagate. But this apparently this force of this column force of spheres travels much. I mean, perhaps even instantaneously, and so I don't know what that would do to the ether. But maybe you could enlighten me on that.
Sorry, yeah, Nick has just a comment in about Van Flandern as well. Sorry, what did you say? What effect it has upon the ether?
Yeah, I mean, the ether has heavily dependent on the velocity of light, Lorentz ether.
Yeah, you see, the way I look at it is that the conventional ether is determined by its elasticity properties and so on, and its rigidity properties, and that gives this sort of speed of light, speed of electromagnetic radiation. But you can have a force which is operating. For example, you could say the same thing about electrostatic forces, that the establishment of electrostatic fields is not dependent upon etheric elasticity processes, and therefore the electrostatic field is established almost instantaneously. And the same thing for gravity, the gravitational field. And you've given the reason. So
I guess the answer then is it wouldn't affect the ether if we take the Lorentz ether as being the ether.
That what wouldn't affect the ether?
Gravity. Gravity wouldn't be a problem.
Yeah.
Because
to my mind,
if it's electrostatic, then, as you point out, it could be established almost immediately.
Yes, quite so. And the same thing for gravity. I mean, I don't like things blowing up, as a mathematician like yourself. So I don't like saying but I do say maybe orders and orders of magnitude times the speed of light. It could be 100 million times, or it could be 10 to the power of some large thing. I'll see now. Can we get some of the people up in the green room? But see, Nick doesn't seem to have a camera operating. I don't know there, and some other people. Let me try anyway. Nick, I have you up now, and I can hear some rattling, but I can't see you.
Okay, I'll try and fix that, but let me just make a couple of points. That are supportive of what Dennis was talking about earlier. My cat has been bothering me, so I may be redundant, but Dennis, when you were talking about the experiment about does light curve around the sun, that was Arthur Stanley Eddington. And
I can. My memory. I'm going on 81, and my memory isn't what it used to be.
Me too. So I forget a lot of things. But he was a great fan of general relativity and its mathematical beauty before going and doing the experiment. So I think
that's what motivated him, I think.
Yeah, and so he didn't really have a very objective view of the data. And as you pointed out, many others have said, hey, this is purely cherry picking because the data itself did not confirm gravitational light bending. In addition, Ed Dowdy, who worked for NASA, says the NASA data shows that light is bent by the sun only within the corona, and that's due to a change of the index of refraction.
Yeah, that's the sun's atmosphere is the corona, yeah.
Exactly. So the light is bent by entering into the transparent corona, but it's a different index of refraction
a fair amount
that bends it.
Yeah.
The other point is that the British physicist Paul Davies had written rather extensively that relativity is a religion. So that again confirms what you were talking about earlier.
Yeah, that's so true, Nick.
Yeah. Regarding general relativity, first of all, the core of general relativity is non-relativistic. It's unlike special relativity, where all these different observers are claimed to have equally valid views, even though they contradict each other. In general relativity, there's curvature that's dependent on mass. And while someone who's enclosed in a spaceship may not be able to distinguish whether he's on a planet or accelerating, general relativity does not say that those are equally valid views. He's saying the single valid view is that the mass is causing this curvature of space and time. And by the way, while experiments so far have never been able to detect curvature of space and time, the fact that it's a non-relativistic view, others have come up with different models on space-time curvature. In fact, Ron Hatch had a theory that these problems were due to the changing density of ether as one went out. Now, one place where the prediction of general relativity is correct is in GPS, where clock rate is a function of gravitational potential, just as general relativity predicts. But that doesn't mean that the general relativity interpretation of space-time curvature is correct.
No,
but it appears that his non-relativistic equations may have some validity.
but the thing about the elevator experiment is that it encapsulated the view that it's not forces, it's acceleration. And because everything falls at the same acceleration, if there's no friction or anything. And Newton originated that idea. He thought that, I have a book here, Cambridge Companion to Newton. And he thought that mass and weight were the same, which is an old-fashioned way of saying that the equivalence principle that God, how do I put this? The gravitational mass and inertial mass are the same. Gravitational mass occurs in Newton's universal law of gravitation. F is equal to capital G is constant times the distance divided by the distance between them squared, and the product of the masses. The masses are gravitational masses, whereas his theory of mechanics, is inertial mass. F equals ma. Well, m is the inertial mass, but he assumed that those two masses were the same in his theory. But Dmitriev has pointed out that they're not, and so what are you going to do? Why don't they accept this? Well, they do accept it more in Russia than they do here. Here, if you were in academia and you announce that inertial and gravitational mass aren't the same, and you're going to do an experiment to show it, your history. And especially if you're in the physics department. Whereas in Russia, you can even publish short articles pointing out that that's not true experimentally. But when Alex tries to get his experiment on board a spaceship, they draw the line there, because then they'd have accuracy that it would be harder and harder to overlook. So I don't believe he's going to get permission. I don't think he will. And he's been trying for a long, long time, too. And so that's a sad story. It's politics. And not more in politics, it's religious politics. Sort of a church and state merger.
Yeah, one last supportive comment on that topic was that, again, outside the very small core of the general relativity's field equations, where general relativity went wrong when they tried to broaden its scope beyond the field equations, was the principle of equivalence, which you were talking about. And again,
Yeah.
Ron Hatch says that the GPS data shows that's wrong. And the other area they went wrong, it was when, in trying to broaden things, they brought in a lot of the problems of special relativity, so that general relativity had a much broader scope. So thank you very much.
Oh, you're welcome.
Well, thank you, Nick, for those comments. In addition, just a quick question, Denny. Do you think that the atmosphere in a place like Russia, with regard to scientific openness, is superior to that in the West, or is it merely that if one published something that was consistent with Dmitriev or some other Russian scientist, one would have an easier time of it?
Well, the things seem to be a little easier in Russia than here. They must know, that some of them anyway, that Ron Hatch, whose invention of the Hatch filter for the GPS system made it so incredibly accurate. But they must know that there's something fishy there, because before the GPS was successful at all, there were papers published by physicists that said, these engineers just don't understand special relativity. They're just ignorant. They'll never succeed. It's wasted money right down the drain, and so on and so forth. Well, they did succeed. So then did they apologize and say we're going to have to rework things? No. They just shut up. They kept, they didn't talk about it anymore too much. But then finally Ron Hatch dies, the last great GPS people, and now they're claiming that it follows from general relativity and special relativity. And if you don't realize that, you're stupid. You just don't really. Maybe you could bring up Ron's paper. You brought it up for a second there.
Yeah, Ron's paper.
Remember that you brought that up?
I do. I just have to find out which one it is now.
I think it's the third one. Maybe
new theory, is it?
What?
Let's see now. Yeah, it's a new theory of gravity. I'll bring that up if you just give me a second now.
Okay.
Let's see now. Now let me see. Don't know why this thing is Not taking it. Ah, here we are. Okay. It's uploading now. Right. Is that it?
Yes. Now, this is, he starts out by refuting general relativity and continues on. Can you space it up a few? Until you get to equations 18 through 20. It's no, you keep going. Yeah,
Keep going.
keep going. Go on. Go on. Okay, one more. Okay, now here on equation 18, we see how inertial mass transforms in the usual way. Wait a minute. My eyes are not good. I'm going to have to look at the actual paper. I don't have it.
Yeah, it's a bit hard to do it.
Yeah,
On screen.
anyway, equations 18, the equations on this particular page, 18 through 22, show that gravitational mass transforms under higher velocities one way, whereas inertial mass transforms a different way. So they couldn't possibly be the same, I mean, even equal. Is there some way to make this make this bigger?
Okay, I can try that. Let me see.
The lower right hand quarter. Can you bring just the lower right hand quarter so people can read it?
I think I've wait a minute now. Is that any better?
No.
See, I just maximize my own screen, and now I can read it. So I think everybody has to do that for themselves.
How do we maximize?
So at the bottom right-hand corner of there should be a little square, and if you click on that, you'll maximize it.
Oh yeah, yeah. Okay, now you can read it now. Let's
Right.
see.
So everybody has to do that for himself, I'm afraid.
Yeah, the equation 18, it gives it defines m. Let's see.
That's the rest mass.
Yeah, and that's the total. The total is the sum of inertial and gravitational. See that the inertial, of course, moves in the usual way. M v squared over 1 minus v squared over c squared. That's kinetic energy. But the inertial mass transforms differently. Instead of dividing by 1 minus v squared over c squared, you multiply by it. Anyway, the point is that if you want high precision, which the GPS people wanted and got, you've got to jump special and general relativity both. Although some of the stuff that they've done goes over to a higher precision theory. On equation 18, for example, on the far right, you get the usual SRT formula. Anyway, the whole thing is a religion. You cannot, they do not want to. They do not want to read your paper, and so on. I had two people recently that didn't want to hear it. One was Vivian Robinson, an Australian physicist who works in electron microscopes. He's not so much of a theoretician as a engineer builder. He can build electron microscopes that work. That's something that's not easy, I'm sure. And he tells me that no, general relativity is right, and he sent me a paper of his. And I sent him some stuff, and that can't be right, and he's made up his mind. And he's not a crackpot or anything. Anyone who can build electron microscopes that work and you can sell them can't be a crackpot. The other one was, I'm trying to think of the other one's name. Oh, my memory. Robinson, who was the other one? Maybe it'll come to me in a minute.
But by the way, this Morton Spears person, was he an academic?
No, he was not. He was an industrialist.
Okay.
And his hobby was gravity.
Hmm.
And he was a successful entrepreneur as well, I guess. But there was some other guy who, was in the news recently, stood up to the climate change mob, the woke mob. His name was William Happer. He's a professor emeritus of Princeton, and he's responsible. He was in charge of the project where they built what are known as spin pump lasers. These are lasers where the electrons, which have a spin, of course, the spin is increased, and then they let this situation decay, and they let the electrons emit light, laser light, as it turns out, and it worked, And recently, he and a professor emeritus of meteorology, I believe it was, at MIT, testified in Washington, I guess it was, Washington, D.C., here in this country's capital, that the climate change hysteria was a hoax. They called it wasn't Happer that called it a hoax, it was his colleague, but Happer agrees. And I have here a newspaper, the Epoch Times. It has an article on that. Maybe you can read that. Is that readable, Ian?
A bit small, Denny.
Well, can you get rid of Ron's paper and bring this up then?
I'll try. Let me see now. No. Okay, it's a bit bigger. So what did it say there? MIT scientists say EPS climate probably a hoax.
Yeah, hoax. Yeah, I recommend this newspaper, the Epoch Times. Anyway, they pointed out that the climate change models do not give the right answer, if you try them out. He pointed out that the data published now about climate warming has been altered from the ones they published years ago, and altered it so that it looks like things are coming to a horrible conclusion, whereas the original data did not say that. And some other things, it's just I don't know. It's the whole thing is a nightmare.
But by the way, I think Nick has one more comment, and while he's there, maybe I'll try to bring him up again.
Okay.
Did you want to add something, Nick? There.
Yes, Ian, I thought you made an interesting point about it being easier in Russia and, in fact, China to publish things that are counter relativity. And I used to discuss this with Ron Hatch, with 30 plus patents in GPS. And while the administration of GPS says it's based on special relativity and general relativity, Hatch, the expert on the technicals for GPS and the data, says, it actually disproves both theories, or at least part of both theories. It's consistent with the field equations, but not the rest of it. So I said, well, isn't this a big problem? Because if Russia and China are using accurate physical models and we're using inaccurate physical models, doesn't that also give them a military advantage? But Ron said yes, but he said that point would not make any difference with the GPS management. So they could not be candid. They could not become bad guys to academia. They had to sing the academia mantra that it was built on special relativity and general relativity. So that was my added point.
That's right. That's right.
Thank you very much. Because it might be put to us, people who think like we do. Well, if conventional scientific progress over the last 100 years has been so dogged by all these incorrect ideas, how have we not suffered technologically? You see, the funny thing is the technologists get things working. I mean, they say, oh, we'll have to get GPS working. Oh, we'll use relativity. Of course, actually, they're not using relativity. They're perhaps doing the opposite. Actually, they're taking out the special relativity ideas, but they're getting things working. So it would be interesting if we do find in the coming years that maybe the West is suffering from this this type of dogmatism, like maybe it did with medieval religion, hundreds and hundreds of years ago.
The correct theory, which is a preferred frame theory, has the same math equation as special relativity, but if and only if you use the GCI frame, the preferred frame, as the base for using absolute velocity instead of relative velocity. So because the math looks the same, many people who are GPS engineers who are not aware of these two alternatives think they're using special relativity.
I don't know. From what I hear, the GPS people know quite well that their theory differs from special and general relativity, but they want to keep their jobs and keep it. They've got kids in college and stuff like that.
And Ron mentioned
go ahead.
Ron mentioned the same thing in NASA, where they thought, the engineers thought they were using relativity, but he pointed them out. Well, you're using the solar barycentric frame as the single preferred frame, and you think you're using relativity. No, you're not. And he couldn't get through to them because the math looked identical.
Yeah.
The application was totally opposite.
The point I was going to make with Happer and this Vivian Robinson in Australia is that these people are not fools, and they're apparently quite honest. At least, I mean, you got to be honest and so on to take on the woke mob or the climate change mob. Even, of course, both of them are retired, so they can't be fired. That makes a big difference. But they can still believe in special relativity. Happer believes in it because he uses a ECI frame, as Nick pointed out. I think that's his. That's why, and it works for him. And so it's extremely unlikely that he's going to worry too much about somebody showing it's incorrect. And Robinson works with his electron microscopes, and he uses the ECI too, so everything's fine. So how can there be any problem here? Get away from me. So it's not just a matter of corruption. These two scientists although I'm not on their list of people they admire, I admire them. And I understand that why we're differing, I think. It's that they're using the ECI frame, which is all right in SRT, but Ron Hatch used the solar frame. He was interested in the inner planets and seeing if time could be. He was a very devout Baptist. He was interested in seeing if the biblical way of looking at time was correct, and it turns out that it was, as far as he could determine with the extremely precise GPS system, which relies heavily on one of his inventions, the Hatch filter.
I don't know if any of you have noticed recently, I don't know if I'm imagining it, but just in the very recent past, you have people like Roger Penrose, for example, who in the past would never have questioned the orthodox theories, but he's coming out with YouTube videos saying, oh, string theory is probably nonsense, and maybe we question the Big Bang, and maybe we question Hawking's ideas and so on. I don't know if you've noticed that, just within the last months, maybe.
No, I haven't noticed that at all.
Yeah, and maybe questioning some of the aspects of the Copenhagen quantum mechanics. So I'm just wondering if a new departure is arising. By the way, yeah. So thanks very much for that, Nick. It's the moment we had a new gentleman. I think Alan might have been the name or something like that, or Denny actually, but he seemed to have his name, but he's gone. But Cornelis is here. I'm just wondering if you want to say something briefly, Cornelis, since you're in again on the green room. If you're there, you're mute and you're no mic, no video. So maybe you're not there at the moment. No? Cornelis, no, you're not there at the moment. Okay. Because we've nobody. Yeah, we've nobody else in the green room apart from Nick, who's made a number of contributions. Well, let me just see. We're running out of time now. Just to see, are there any comments coming in on the general? Oh, there he is. Just say he heard us, but he had to get here. So
I'm outside.
Go ahead.
We're on the telephone, so I had to come in to answer the prompt.
Okay.
I have been listening, but I haven't really been watching, and it's kind of intermittently between my wife talking and Denny talking, and so
right.
So what I've caught of it anyway is as far as relativity goes, I don't think I'm going to touch that because there's too much controversy about that. With the ether, you're talking, Ian, about the speed of light, which is a transverse wave. And then there's also, in any solid medium anyway, continuous medium, there's also always a longitudinal wave. And so that longitudinal wave typically, if not always, almost always propagates faster than the transverse wave does. We haven't really been able to or discovered any longitudinal waves that are responsible for gravity, but I believe that's just because of their length is so extremely small. they're also responsible for the creation of mass in that. But as far as the spinning gyroscope there, let's see. There was I'm trying to think of the name of the fella that said that Einstein based his theory on that mass, the inertia was affected by what was out there and not immediately.
Perhaps.
Mach.
Yeah.
Mach's principle, basically, yes. And so basically, if mass of an object extends far beyond what we physically see of that object, when you rotate that object, you're rotating its image or the continuation of that object far out in space. And we also understand that mass increases with velocity. And so the farther out you are in space, the greater the velocity of that object's diameter would be. So what you're doing is you're really displacing the mass of that object. You're increasing it, but you're also displacing the mass outwards at the same time. And if it's way out here, and you have your object here being attracted to it here, then you get a greater and greater angle of where the mass is. There's some mass out here, and there's some mass out here that's part of it, and that mass is extending out here. It's greater out here now than it is in the middle. So you really actually, the gravity is not pulling straight down anymore. It's got to pull that entire mass towards it, and if you go far enough out, it's actually perpendicular to the object because it surrounds it. The mass of an object isn't just right there at the center of the object. We always idealize the mass as being the center and the visible portion of an object. But that if Mach's principle holds, then that's not true. The mass is actually affected by far out. And so consequently, a rotating object, a spinning object, would have the mass redistributed the faster it rotates to a more distant direction away from, and not necessarily vertical from the mass that's attracting it. I'm not real great. I've worked in electronics all my life, and I'm not a real great proponent of capacitive gravity. In my view, gravity is part of it, is due to the transfer or the propagation of longitudinal waves that we have not yet detected. We say we see gravity waves, like you said, Ian, but the gravity waves are just a modulation of the gravity field, which is created by these waves and carried by these extremely short waves. And so that's what we're really detecting, is that modulation of those waves. And in other words, a carrier wave would be the real wave that generates the mass. I don't know if there was other things, but like I said, it was good listening to you, Denny, and there's a lot of food for thought there. I don't really, and I have Ron Hatch and I have, we've talked before about the wave properties of matter, and that his electron model and mine are fairly close. I happen to have his book that he signed for me, and I don't see where he really, is a strong opponent of relativity. Special relativity is kind of like its history as far as I'm concerned, and it's general relativity that deals with gravity. And the general relativity I consider to have some meat in it. The mathematics, I'm not versed in mathematics enough. I'd love to be, but in the same sense, I don't have that kind of time. I enjoy whatever. So I think those are the comments I have about your talk, Denny. And thank you for prompting me. I'm going to get back out. I'll listen to you, and I'm going to go out and pick some more grapes.
Well, thank you very much, Cornelius, for those comments.
Thank you.
And, I'll just, unless Denny has anything pressing, I may, in the very short period of time we have, ask Jim Morrison, who's just come up at the 12th hour into the green room. I'm not sure if Jim wanted. You seem to have sent me an invitation recently, which I accepted, but it wouldn't go forward. So I don't know what that was about. I seemed to lose it. So, but you've just appeared now. Yeah. Did you want to make a point, Jim?
Hello, can you hear me?
Yeah, I can hear you now.
Yeah, sorry, I was out of sync there.
Okay.
Yeah, I don't know if it's a little off topic or not, but it was mentioned about the speed of light and the dependence of atomic clocks, GPS atomic clocks on speed with respect to the ECI and the gravitational potential. There's been a lot of discussion I've seen about how to explain that without invoking special relativity or general relativity. And I just wanted to mention that there's a physicist named Ching-Chuan Tzu who developed what he called the local ether model, where his ether travel is essentially part of the similar to or in the same related to the gravitational potential. So around the Earth, there's a halo of local ether that moves with the Earth, does not rotate with the Earth. It's at rest with the Earth's central, the ECI. And he developed an equation he called the local ether wave equation, which then he derives the dependence of the rate of atomic clock clicking in orbit as due to essentially change in the orbital energy of electrons in the atoms that make up the clock rate. So there's a way to explain that part of the GPS system without invoking general relativity or special relativity. It comes up with the same equations, or the same dependency, I should say, on distance from the center of the Earth for gravitational potential, and the gamma factor for speed with respect to the ECI, using his local ether wave equation and applying it to quantum mechanics. So transforms, Solari transforms, Lorentz transforms, whatever, are not needed to be invoked to explain those things. And I recommend everyone check out his theory. I can provide some links to his papers if anyone's interested.
Okay, well, thank you very much for bringing that matter up. I think you have referred to it on a previous occasion, but in relation to today's talk, thank you very much indeed, Jim. And I think just before closing down, any quick comment you want to make, Denny, before I close the meeting?
Well, I forgot to mention that one of the big features of Morton's theory, which makes it even better than Newton's theory, apparently, is that you can compute Newton's gravitational constant to more than 5 significant figures. And that's because it's left out of Newton's work on gravity that it's electrostatic, and hence the permittivity or the dielectric constant has to come in at some point too. Now, Spears talks about this, but he isn't talking about the usual dielectric constant, but the one for the column field, which is 10 to the 40th smaller. And So from that point of view, in space, even though it might be a dense metal, from that point of view, it's little tiny pepper-like dots in empty space. And since there's no displacement and no displacement current, you get that the dielectric constants of various substances with regard to this column field are different, quite a bit different, very close to one. We're very close to epsilon sub zero in the MKS system. But significantly different. For example, there's something called tower gravity, where people drop things off a tower and measured very precisely how fast they fell. And it seems like there's some discrepancy from Newton's theory, which as Spears pointed out, might be explained by his capacitance theory of gravity. So Spears's theory opens up whole new areas for research. GRT and SRT open up things like dark matter and dark energy, which have led nowhere. They've opened up things like gravitational waves being detected by LIGO. But KAGRA, the new one that's come online, doesn't detect them. And Richard David Scott, for example, an astronomer you can find on ResearchGate, has pointed out that the gravitational wave detections are heavily biased when the sun and the moon are in certain portions of the Earth's sky. And the sun and the moon, of course, control the tides and the tidal forces that occur even on land. So it looks like that what the LIGO people are picking up is not gravitational waves. It's what's the word? It's tidal wave, tidal forces. So it's too accurate. It's too sensitive. Excuse me. It's not too accurate. It's too sensitive to things like tidal forces. So which it's picking up apparently, since they usually their detections are certainly usually in cases where the sun and the moon are in certain positions in the sky, but these gravitational waves are supposed to come from way outside our galaxy. So how could the fact that the sun is over here and the moon's over there make any difference? The whole thing is another hoax, apparently. Well, this isn't the first time it's happened. Professor Weber had his aluminum gravitational wave, cylindrical aluminum antenna, and that turned out to be an apparatus effect too. And why don't the KAGRA people pick up anything? They don't pick up anything because there's nothing to pick up, and they're not so sensitive that they'll detect fault signals coming from tidal forces that occur, as I say, even on Earth. People think the tides is something that's in the ocean, but that's not completely true. You can look it up. There are tidal forces on the Earth too, land. So no matter how you look at it, if you look at it through the lens of helpfulness, well, who is helped by the detection of gravitational waves except the LIGO people who get big contracts from the government? Who is helped by what was the other thing I brought up? Dark matter and dark energy. Who has ever benefited from that? Well, apparently it's a fantasy, which is spawned by the GRT fantasy. And it's sort of like religious, like a Stonehenge in England. You know, when the sun was at the spring solstice, certain shadows were in certain patterns and so on, and that meant that the harvest would be good. You know, it's if you study this too long, you're in line for antidepressant drug.
Well, thank you very, very much for all that. I mean, it's very stimulating. You've given us some very hard science, but you've also given us a context, philosophical context, and a context concerned with human psychology and perhaps the propensity to wish to have simplistic, religious, unquestioned ideas, and even historical ideas, dare I say.
Yeah.
So, and you've raised a lot of points. Actually, you've given a lot of information there, which we didn't have time to go into in detail. But I know, if I may say so, if I may speak to you to a certain extent, you'd be more than delighted to go into more details. If any of our participants, either the regulars or indeed through the Facebook and YouTube, if they want more information on any of the aspects that you did raise, I'm sure you'd be happy to provide
Yes.
that. So there's a lot of information there, I can tell you.
And you've got my files too. You could you've got those 5 files. You could send them out too.
Yeah, okay. The files are available, and you've published actually a bit on the what's that thing you use? One of those formats where you can publish your papers. You've put quite a bit in there.
Yeah, Kindle Direct Publishing.
Yeah, but also one of those online scientific paper submissions.
ResearchGate and academia.
ResearchGate. Yeah. So if you go to ResearchGate, dare I suggest it, and look at Dr. Dennis P. Allen Jr., you will get some of your interesting contributions there, dealing with everything from electrostatic capacitance theory of gravity to electron spin models to you've dealt with so much, and inertial mechanics and so on. So there's a lot there. I'd like to thank you very, very much for giving us this talk today, which I think has been a nice departure from our sort of more regular ideas with regard to alternative ideas in physics. And what we're hoping to do is, in the near future, maybe next, reverting to a Newtonian electrodynamics. Maybe the works of the Granos. So that's sort of we have down, and we just have to formulate that. So I'll bring you down, Danny. Thank you very much again for taking the significant trouble and sending me all those files, which I now have. If anybody wants them, they will be available. And I'd like to thank you all for contributing as usual. We had a very small group in the green room, but you all made your points known. And thank you for contributing to that. The comments were coming in bilio on the social media, and my apologies as usual if we didn't have an opportunity of maybe addressing them all. We addressed some of them. Others were really just discussions between yourselves, and I think they'll be ongoing. So please keep at it. Keep up. Don't quit. Come back to us and criticize us and ask us more questions. And we hope to see you next time. It will be hopefully in 2 weeks' time. We're not able to run these things every Saturday, but our aim for the present anyway, probably for the rest of the year, if we can manage it, is to have fortnightly meetings. And I'd actually invite any suggestions for speakers or subjects, because we will be running out later on this year. So just a couple of minutes over time. I'll leave you all to your other resources in whatever part of the world. I think most of you, it's probably midday. It's pushing on now for the evening meal, I think. And I don't know if we have any people further west for whom it's late at night, but I'll wish you all a very good day. Thank you very, very much for attending today's lecture by Dr. Dennis Allen. So I'll end the broadcast now.